Hey guys, welcome back. In this video, let's talk about queue, another wonderful data structure. Okay, in other linear data structures, we have one more interesting data structure called as queue. Queue is almost similar like a queue in a real world scenario, guys. So, say for an example, that's a ticket counter here. Okay, and people would form a queue to buy tickets, right? All right, so this is exactly a queue. Okay, so we are going to implement a similar kind of thing, but you have two ends, right? One is called front end and another one will be called as rear end. And one important thing to note here is queue follows a principle called FIFO. That means first in, first out. One who makes to the ticket counter first will be the first, will be getting the tickets and will be the first to go out, right? So it is actually first in and first out. That's very important. Of course, I'll explain with this example. Don't worry, but this is very important, guys. This is first in, first out. Okay, please remember that. Okay, so let us take an example. So you have two important pointers called as front and rear. Okay, front will point to the front end of the queue and rear will point to the rear end of the queue. Okay, so these are the two important keywords, guys, as far as queue is concerned, right? And both the value will be -1 in case there is an empty queue. Okay, if there is no empty queue, then you have to increment the value. Okay, according to that. Okay, I'll teach you how to do that. Okay, so this is a queue. Say I have empty elements. So now my front is 0, my rear is front is -1 and rear is also -1 because there is no elements in it, right? So actually, if you see, this end is called as front end and this end is called as rear end. Okay, all right. So again, the basic operations are insertion and deletion, guys. Insertion is called as enqueue. Okay, insertion is called as enqueue, which is given by this, and deletion is called as dequeue. Okay, so these are the two very basic operations that you have to understand in case of queue. Okay, insertion is called as enqueue and deletion is called as dequeue, guys. But you can't do that from both the sides. Okay, understand that from in the front end. Hold on just a minute. In the front end, you can do only dequeue process. I mean, you can delete elements from the front end, and from the rear end you have to enqueue. You have to insert elements from the rear end and you have to delete elements from the front end. All right, and this should be done. Okay, please remember this. From front end you have to remove elements, from rear end you have to insert elements. Okay, you have to insert or enqueue. Enqueue is a good word, right? Okay, let's see an example. Let's check. This is my queue. Okay, and I have front equals to -1. Of course, rear is also -1 since there is no element. Okay, I'll say enqueue5. enqueue5. Okay, will that be fine? Yeah, enqueue5. Okay, what you have to do here is you just have to increment this rear. Okay, rear by 0 now because you are entering the first element, so rear by 0, and you are supposed to enter here, guys, 5. Okay, you have to traverse this and you have to enter at the first element. Okay, so 5. Of course, you are going to implement this using arrays only, so consider this as an array. So front is if front is -1, make it also 0 because you got an element here. Okay, for the first case itself, if front is -1, make it 0 because you got an element. Okay, that's why. So front points to the same element, rear points to the same element, right? And again, I'm enqueuing one more term, guys, maybe 10. Okay, what direction I should do? I should do only in this direction, right? So if you see, 10 will come here and my rear will become 1, right? R will become 1. Front value will remain the same. Okay, only for dequeuing you can change the front value. But if you are enqueuing the first element, in that case you have to change -1 as 0. That's it. After that, the front value remains the constant. Okay, let's say I want to enqueue one more element, enqueue 105. Okay, so you have to, in this direction you have to put, right? So in this direction let's put 105, and you make rear to be 2, right? For first element the rear is 0, rear is 1, rear is 2. So rear also points to the, always points to the last element, guys. Okay, all right. Now let's say, okay, NQ is enough. Let's go for a DQ. All right, let's say I just wanna DQ 5. Okay, DQ should give like this. Okay, it's almost like a pop operator in stack. So give DQ alone, it will remove the first element in the front, guys. First element in the front. So this will be removed. This will be removed. How do you remove that? This will be actually there. You just have to increment front. Front is pointing to 5, right? You just increment front. You just increment front by 1. So when front equals to 1 means it is pointing to 10 now. Okay. When front equals to 1, which means it is pointing to 10 now. Okay, you don't make it 0, since it's clear that now it has been deleted. Okay, if you DQ it again, again front becomes 2 and it will be pointing to 105. Okay, so that's it. So what are the main aspects that you have to do for, if you want to enqueue something, increment the rear. Okay, increment the rear, and in the queue just assign like this, enqueue the value that you have to enqueue. These are the two crucial statements whenever you have enqueue. Okay, and DQ, when you want to DQ something, just increment the front. That's it. Okay, because front is the front points to the first element. Okay, if you increment the front, then it points to the next element, and that becomes the first element. All right, so even if the previous element is still there, but we don't want that, right? Because we just want to track the elements using this front and rear. So increment the front, it will point to the, it means that it is pointing to the second element, so that becomes the first element, and the first element is already deleted. Okay, so almost one thing I wish to tell you here is, so let's say I have enqueued 5, 10, 15 and 20. Now our rear will have the value 3 and it will be pointing to here. Front will have the value 0, will be pointing to here. So I am DQing in this direction, right? Only in this direction I can DQ, right? So first I'll DQ 5, I'll DQ 10, I'll DQ 15. Okay, alright. So I'm enqueuing 5, 10, 15, 20 in the first, and then I'll DQ 5, 10 and 50. Okay, now it is, what is the value of front? Front becomes 3. Alright. Let's see one disadvantage of queue, guys. Let's say I have a queue like this. Okay, so it's empty. So let me enqueue some elements. Let me enqueue 5, 10 and 15. And what's my rear value now? Okay, I'll enqueue 20 also. What is my rear value? My rear value becomes 3, right? Because it is 0, 1, 2 and 3. Okay, alright. So and my front value is 0. Understand that front value is 0. Okay, so if you want to DQ elements, let me DQ 5 first. So if you DQ 5, front value becomes 1. I'll write that later. DQ 10 also, DQ 15 also. What is the front value now? Front value also becomes 3, right? Also becomes 3. Alright, so this is my front value now. Okay, so now after you insert on one more element, 25. Okay, if you insert one more element, say 25, you can enqueue one more element, right? You can enqueue one more element, 25. Okay, and you make this rear to be 4. You make this rear to be 4 now. Okay, so I just want to enqueue one more element, guys, 30. Is it possible now? Is it possible? Can you say is there is an empty space? Okay, no, of course these 3 are empty only. We have DQ'd elements, but The disadvantage here is we can't go back and insert elements here, guys. Okay, once inserted and deleted, that's it. Okay, you can't go back. Okay, you can only increment rear in this direction, so there is no another empty space here. So this condition is called as queue overflow condition. Okay, queue overflow condition. I hope you remember about stack overflow. This is same as like that. Okay, queue overflow condition. All right, so please have this in mind. You even if the queue is empty in this direction, you can't insert that. Okay, you can't insert any elements. Once used, will not be used again, so you have to insert only in this direction. So that's one of the biggest disadvantages of having queue. Of course, this disadvantage is overcome by some other type of queue called as circular queue and things like that, but we are not going to discuss about that in this course. Okay, so I hope queue is very clear to you, and we'll execute the enq and deq algorithm in the next video. Okay, enq and deq algorithm. Thanks a lot, guys.